looking at is over solving equations and inequalities. Hopefully we all say, yep, we've done that before in middle school. Agreed, agreed, agreed. We cannot do anything with algebra if we cannot solve equations. So we want to just make sure we all have that same solid ground. We're all good to go. There are sometimes you can solve equations different ways. So if you do something slightly differently and you need to check with me, like, hey, does this still work? Yep, it's great, it's okay. But sort of just our basics here, I want to sort of go through a quick run through of our basic rule with 1 and 2 step equations. Hopefully, we are all on board with the idea that to solve an equation, we do inverse operations. Okay, so what's our inverse of addition? Subtraction. What's our inverse of multiplication? Division, and those work both ways. Right, so if we see multiplication, we use division. If we see division, we use multiplication. Do we know what order we decide to solve an equation in? How do we know what to do first? Or it's just, oh, my teacher's always told me to do this first, so I should do it first. Okay, when we are solving an equation, we are actually doing order of operations backwards. So it's not a random pick whichever you think is best. We need to do order of operations backwards, which is why I said it was important yesterday that we agreed multiplication and division came together, and we agreed addition and subtraction came together. So I guess if you really love PEMDAS, now you're going to think SADMEP. I mean, if you want to write PEMDAS backwards. So we're doing SADMEP. Okay, I'm not going to do the very basic things. I am just assuming at this point and at this level that we are okay with the very basic things. I just want to put up here the ones that are the common problems. Okay, the common things that I see with students. So, my students have no problem telling me that if I have something like x plus 2 equals 12, we undo addition with subtraction and we would subtract it from each side. But as soon as a double operation shows up, then things get a little bit more questionable. Okay, so if we have something like x plus negative 5, this could be written to include parentheses as well. It may or may not have them. It's fine either way. Anybody say they have a thought of what they would like to do to solve this? Mitch, what do you say?
Add 5 to the 10 and then it'd be x equals 50.
Okay, why do you want to add the 5?
So it gets the 5 to the other side, so it's just x isolated by itself.
Okay, but don't I need to do an inverse operation? Is the inverse of addition subtraction?
Yeah.
So then I want to subtract 5?
But it's negative 5.
Oh, so then where are you getting the subtraction from? I'm playing devil's advocate here, just so you know. I want to see if you know why you're doing what you're doing.
I don't know, because my teacher told me.
Because my teacher told me to. Is that what we agree with? How many of you say my teacher has taught me to just add 5? And I just know I want to add 5. Now, there are 2 ways to approach this. Option number 1 is Mitch's approach here, which is I'm adding 5. Now, the reason why we are adding 5 is because if we have 2 operations, right, this is a subtraction or a negative, this is a positive or addition. If we have 2 sitting side by side, it's easier to solve if there's only one thing happening there. And how could I rewrite this with only one sign? Logan, maybe? What do you think? X minus 5. This is the same thing as x minus 5 equals 10. And how do we undo subtracting 5? We add 5. So that's why you are adding 5, is because really the operation that is here is subtraction. That's one way to think about it. If you're not sure what it turns into, think about this as multiplying a positive 1 times a negative 5. A positive 1 times a negative 5 is a negative 5. Okay, and that's where that sign comes into play. The other way that you can think about this is that you always just want to use an inverse operation. Okay, and to find the operation, we look in front of the number. What operation do we see? Addition. How do we undo addition? Subtraction. What number do we want to move? Not 5, but -5. So we want to subtract -5. And subtracting -5 is adding 5. Okay, because my students will say, well, I don't know, my teacher just told me to add 5. What happens if I write this then?
Subtract 7.
Why are we subtracting 7?
Because 2 negatives make it positive.
Okay, so if we clean this up, right, 2 negatives make a positive, and we're rewriting it with 1 sign, just like we did over here. And so this becomes a y plus 7. Okay, do I have anybody in here who, like, desperately needs their variable on the left-hand side? Do I have any left-hand side variables? Don't do it. Don't do it. I know it's terrible. Our teachers have said, oh, no problem, just rewrite it and put this over here on this side, right? Yeah, that's not gonna work very well when we do some other problems later, nor is it gonna work when we have lots of variables happening later this unit. Okay, so if you've always flipped and rewrite it, see if we can't start to break that habit and accept, okay, my variable is over here on this side, so I'm just gonna ignore this. Just don't look at it. What would I do to get rid of that 7? I would subtract it, and instead of writing it over here, throw it over here. If you need to rewrite it at the very end, then you're okay. Okay, we say we're okay there. That's pretty straightforward, right? Just make sure we're okay on that piece. Don't let this throw you off, because this is probably a problem you have avoided in the past. Do I have anybody in here who is an Xer only? I need an X. If it's not an X, that's a problem for me. If you're one of the people who changes all of your variables for X, don't do that either. It's going to be a really big problem when we have X, Y, Z's, and W's in the same problem. If you turn them all into X's, then that'll be really bad news. Okay, so again, try that new habit here. Let's try and create some better habits that work long term. So I know lots of students in the past, when they look at a problem like this, they're like, ooh, I don't do fractions. Nope. Avoid. But now at this point, should the fraction even faze us? Because worst case situation, we could use our calculator, right? So we have a way to deal with the fraction. So now we're just focusing on the equation. What do we need to move first? The 7/5. We have to get rid of that. How are we going to move that 7/5? Okay, we're going to subtract it. Subtracting is correct, but again, I'm going to push you to make sure you know why. I don't undo subtraction with addition, so why am I subtracting it? Because it's positive, right? This sign has nothing to do with the 7/5. We always look in front of the number. Is that 7/5 positive or is it negative? Positive. How do we undo a 7/5? Subtract it. Okay, and then if you say, I don't like fractions, what are you going to do next to do 2 1/4 minus 7/5? You're going to pick up your calculator, right?
I got
17 20ths.
Oh, 20th, duh, I had 20th. 17 20th. Are we done?
No.
Nope, why not?
We need to switch the sign because the.
Okay, so this negative is still part of this W. Now, this is where things start to open, and I'm fine with any of them. Some of my students say, well, I just have been taught to switch the sign and change the sign of both of them. Fine. Some of my students say, I've been taught that there's a secret ninja 1 here. That would be because of our identity property of multiplication, and I will divide by the -1. Some of my students will multiply by, I don't care. but we should be able to get rid of that negative 1 and get a negative 17 over 20. Are we okay with that? Okay. So problem over here on the left, 1/3 y minus 4 equals 8. What am I going to do first to solve this equation? We all know the answer. I fully believe we all know the answer. What do I need to do first to solve this? Add 4. Do we agree? Yes, of course we all agree because we've been doing this for like 2 years. Why am I adding 4 and not getting rid of this 1/3? Because that's what your teacher told you to do? Is that really why? What do we undo first in an equation? Addition and subtraction, because we do order of operations backwards. That's the why. That's the reason why we do it. Okay, order of operations backwards says undo any addition and subtraction first. Okay, so we're going to undo subtracting 4 by adding 4. How am I going to get rid of that 1/3?
Divide by 1/3.
Okay, so then let me ask you this. Would you write it down like this? Is that what you guys would write down? Sometimes my students say yes. Some students do that. There's nothing wrong with writing this. What else do we maybe write down? Do what?
Negative.
Nope. Do any of us write this?
Sometimes.
Okay, so dividing by 1/3 is the same thing as multiplying by the reciprocal. So some students have been taught don't ever write down division, because division you always change to multiplying by the reciprocal. So if you're that person and you're writing this down, I'm fine with that as well. Okay, this is fine too. We just need to divide by 1/3. I think the key piece here that I want you to understand is calculators are great. It's great that we can type in dividing by 1/3. But then when I tell my students 36, like, oh my gosh, how'd you do that in your head? Well, dividing by 1/3 is multiplying by 3. Like, we should at least understand that those are the same thing. And so we get y equals 36. What's the first thing I want to undo over here? Logan? Y. But if I do order of operations backwards, it said addition and subtraction first. So why am I not moving that forward?
Because it's the right thing to do.
Why?
Because it is.
There has to be a y. There is a y on this one. I mean, we said the rule is order of operations first. One of the reasons I like math is because when the rule is the rule, you follow it and it doesn't change. Okay, the rule does not magically change for this problem. So what is different on this one?
It's the y minus 4 is a fraction.
It is, and because it's in the top of a fraction, do we remember what's happening up here? Like, if you were to type this in your calculator, maybe if it was just a number, if we saw this, could we just type into our calculators 1 plus 3 divided by 2 and get the right answer? Ooh, I don't know, try it out. Type in your calculator 1 plus 3 divided by 2.
2.5.
Is this equal to 1.5?
No, it's
It says
equal
2.5.
2.5.
Oh, 2.5. What is this equal to?
2.
2.
2.
So why are we getting the wrong answer in our calculator?
That's a fraction.
What?
Because of the way we put it in.
Oh, it is because of the way we put it in. What would we need to add to make it go in right?
Parentheses.
Parentheses. This is really in parentheses. So this is really in parentheses. And all of a sudden, parentheses, they don't fall until the very last thing. So I need to undo everything else and undo the parentheses last. So I'm going to multiply by 3. Do we write multiplying by 3 like this? Is that how we're going to multiply by 3? What do you guys write? I'm literally asking you, what do you write?
The dot?
Do you guys write this underneath?
Yeah.
I mean,
Okay, the only thing I'm going to tell you to be careful of moving forward, don't write this. Your geometry teachers will take off points. Because you do not want to multiply this 3 all by itself by 3. This whole side is getting multiplied by 3. So be really careful. I know that's something they're really picky about. Those cancel.